Hello friends, welcome to the second session of the Etabs. So in the first session we have studied the steps followed for the analysis and structures using Etabs. So in that we have done the AutoCAD drawing, we have defined the geometry of the building in the Etabs. We have also defined the terms like the material properties, that is the concrete and the steel, the frame sections, that is the size of the beams and the columns, the slab sections, the load patterns, and these two things we will discuss it in the later stages now. Also we have discussed that how to assign the properties to the members. Also we have discussed the joint restraints. In this session we will discuss about the assigning the loads. The loads are the live load, the super dead load, wall load, earthquake load, and the wind load. This is the model which we have prepared in the ETABS. So in this session we will see the how to apply the wind load to the structure now. So before applying the wind load, we need the minimum criteria for applying the wind load is G plus 5 stories now. So let us increase the story height. So if we want to increase the story height, go to edit. In that, edit stories and story systems. Here there are different stories here. Now let us consider a G plus 10 story building now. So now I will go for the modify show story data. Here I am going to add some few more stories now. So by clicking the right click on the button, we will get add story. Just keep the existing story height. Here it gives the story height and number of stories you want to add. So now I am going to add 4 stories now. So press OK. So after pressing OK, here it will come the number of stories, that is up to story 10 I have added now. After this, press OK. You can see that the base up to the story 10. So then press OK. So by pressing in the 3D view, you can see that before my model was up to the G plus 6 stories. After that I have added 4 more stories now. So now let us see how to define the load patterns. As I told that in this session we will discuss about the wind load. So here are the, so before going to that, go to define, later load patterns. So in that these are the two terms which are predefined one. So as I told that we need to add super dead load. So it will be in the form of super dead. So then add new load. Then again we need to consider the wall load. Press wall in the load case, and here the type will be in the form of dead. Then after that add new load. So as I told that we will in this session we will see the wind load, how to apply the wind load. So wind in x direction, press the load as the wind x, take the type as the wind. So here it is asking the IS code now. Since we are using the Indian standard code, it is IS 875 1987. So then next add new load. Similarly in y direction also we need to add the load type. Then again add new load. After adding all these loads, press OK. As we have defined the load patterns, now the next step is to assign those loads to the structure. Before going to assign the loads to the structure, first we will find out the how much amount of the loads should be imposed on that structure now. So for that we need to find out some of the IS codes now. So if we refer IS 875 part 1 1987, it is for the dead loads, and this is IS 875 part 2 1987, it is for the imposed loads. Imposed loads are nothing but the live loads. And the third one is the IS 875 part 3, it comprises of the wind loads. IS 875 part 4, it is for the snow loads, and part 5 is for the special loads and combinations. as I told that we need to refer the codes for the loads which we want to add. Let us see about the IS 875 Part 2 1987, which comprises of the imposed loads. Imposed loads, as I told that these are nothing but the live loads. Since I am considering the structure as the educational type of the building, I want to go it for educational, see whether where the educational type of the building lies. So on page number 8, here there is a educational type of the building. That is, the for classrooms and lecture rooms we need to apply 3 kilonewton per meter square. Similarly for offices, projection rooms, kitchens, they have given some different loading conditions. By looking into these loading conditions, we need to apply the live load on the structure now. I will consider the whole structure as the educational type of the building, and the structure is comprises of the classrooms. So we have seen in the code book that for the classrooms it is 3 kilonewton per meter square we need to apply the live load. So before going to that, first we need to check out whether it is a one story or similar stories or all stories. I need to select it as a all stories now. Already we have defined the load patterns. Now we need to assign them. So since we have selected here the all stories, the live load is applied on the slab portion. So select all the slabs. So after selection all the slabs, I need to assign the loads now. So go to assign. So as I told that it is in the form of shell loads. Go to uniform, select the live load and make it as, here you need to apply how much the amount of load you need to apply now, that is 3 kilonewton per meter square. So after typing 3, go to apply, then press OK. So you can see that the 3 kilonewton has appeared here. So after that, again I have used one term as SDL, that is super dead load. You all have seen in the RCC that we all apply the factor of safety, that is 1.5 as the factor of safety. Similarly in Etabs also we will apply the some amount of extra load on the structure. So again I want to apply the super dead load on the slabs portion, that is the shell portion only. So here is one option, that is get previous selection. If I press this, automatically all my previous selected slabs will get selected. Similarly, as we have assigned the live loads, like that we need to apply the super dead load also. Now go to assign, shell load, uniform. Now take it as SDL. So in SDL, as I told that it will be in the form of 1.5 kilonewton per meter square. Type 1.5, then next apply, then press OK. So whether the loads which we have applied is correct or not, if we want to check means select one slab, right click on that slab now. Automatically the geometry will come, assignments, that is the slab which you all have assigned, then the loads. Here it is showing that the live load which you have applied is 3 kilonewton per meter square, and the super dead load is the 1.5 kilonewton per meter square. After that press OK. Another load which we all have defined is the wall load. The wall load is can be calculated as the height of the floor into wall thickness into density of the brick. The height of the floor which we have taken is the 3 meter, and the wall thickness is the 0.23 meter, and the density of the brick is 20. So by multiplying all these three, we will get the wall load as the 13.8. So that 13.8 kilonewton we need to apply on the kilonewton per meter. We need to apply it on the beams now, because the load transfer mechanism will be in the form of the loads will transfer the on the slabs. The slab from the slabs, these are transferred to the beams. From the beams it is to the columns, and from the columns it is to the foundation. So automatically the beams takes the load of the walls now. So you need to select the beam portion now. So select all the beams. After selecting all the beams, we need to assign the loads now. Now again go to assign, As I told that it will be in the form of frame loads. Go to frame load, then distributed. Here I need to select as wall load. So it will be 13.8 kilonewton per meter. Then after that press apply, then OK. So automatically these loads will be displayed here, 13.8 along all the beams which you all have selected now. Now the major thing lies is the how we need to apply the wind load to the structure now. Now again go to define now. As I told that go to load patterns. Already we have defined the wind x and wind y now. So here only we need to apply the wind loads. So go to wind x. Here is one term, modify lateral load. Press that. Here it will show some of the terms here, that is wind coefficients, exposure height, the wind directions and all. That is the wind speed and all it shows. So these all things we will get it from the code book now. This is the code book for the wind, that is IS 875 part 3 1987, which comprises of the wind loads. So as we can see that the first option is the wind speed it is showing. We need to select the wind speed. From the code book we can find out the wind speed. Go to the last page, that is in appendix A of IS 875, which is under page number 53. You can see that for different regions there is a basic wind speed here. So let us find out that the Bangalore comprises of the 33 meter per second as the wind speed. I will select my building in the Bangalore region. So I will type it as a 33 meters per second. The second one is the terrain category. This also can be found out in the code book only. The terrain category is under page number 8 of IS 875 1987. So here are the category 1, 2, 3 and 4. So the category 1 says that exposed open terrain with few or no obstructions in which the average height of any object surrounding the structure is less than 1.5 meter. So these categories can be selected by looking into the site area. We can select the category. In the category 2 it is found that the obstruction is between the height 1.5 to 10 meter. In the category 3 we can find that the height is about 10 meter. In the category 4 the terrain with numerous large highly closed space structure. So let us assume that the structure is situated in the category 3 region. So by looking into this we need to select the category, that is 1, 2, 3 and 4. So as I told that the structure is situated in the category 3, I need to select the category 3 now. Now the next step is the structure class it is asking. The structure class can be found out in IS 875 part 3 of 1987. It is in the page number 11. So here are the terms class A, class B and class C. The class A suggests that structures and their components such as cladding, glazing, roofing, etc. having maximum dimension less than 20 meter. The class B suggests that it is the height is between 20 and 50 meter. The class C suggests that their maximum dimension is greater than 50 meter. So let us assume that the structure is situated at the class B now. So here I need to find out the structure class. So as I told that the structure class is situated in the B region, select B. Then the next factor is the risk coefficient factor. These all parameters can be got only by looking at the site area, that is where the building is going to be constructed. By looking into this we can find out the terrain category, structure class, risk coefficient and the topography. The next point is the risk coefficient, that is K1 factor. On the same page number, that is on page number 11, we can find out the risk coefficient factor. That is here is the some values they have given. That is for all general buildings and structures. Here are the number of years which we want to construct the building, and here are the wind speed. For different wind speed what is the risk coefficient factor they have given. The first one is of the all general buildings and structures, which is of the 50 years they have considered. In the second part, that is the temporary shuts and all, which is of the lifespan of 5 years. And for building structures presenting a low degree of hazards to life and property in the event of failure, they have mentioned it as 25 years. And the next category is of the important building and structures like towers and power plants. The estimated life of these structures is 100 years. So let us consider that our building life is of the 50 years. It comes under the general buildings. Now we have selected the wind speed as, since we have selected the wind speed as 33, the K1 factor for 33 and for 50 years it is 1 now. The risk coefficient factor, therefore it will be 1. Type the risk coefficient factor as 1 in the Etabs. Now the next point lies is the topography, that is K3 factor now. The topography factor is situated at the page number 12 of IS 875 part 3. Here is the, from table number 2 we can find out the topographic factor. Before that we need to know what is the total height of the building that we are considering. This can be found out by the Etabs model. That is, on the plan view, the story 10, that is of 30.2 meter, is the highest story of our building. So by that we can find out the where the 30.2 lies. It lies between 30 and 50, and the terrain category or class which we have selected, that is A, B or C, and it lies at the terrain category which we have selected is the B class. And for the B class, for 30.2 height, it is 1.13 has the topographic factor. So by selecting now select the topographic factor as 1.13. The wind will be applied up to the story height. So since the bottom story doesn't come under contact with the wind, we can skip the base and we can start from the story 1. From the story 1 to the story 10, the wind load will be applied. The major difference between wind X and wind lies in this portion, that is wind direction and the exposure width. Select the modify or show. Here in this case, since I am selecting the wind wind X direction, I need to select it as 0 degrees. In the wind Y, we need to select it as 90 degrees. That is, on both the directions the wind cannot blow simultaneously. So we need to select the either in the X direction as 0 or in the Y direction as 0, or if you have selected the wind X direction as 90 degree, you need to select in wind Y direction as 0 degrees. So the major difference lies here now between the wind X and wind Y. After selecting 0 here, press OK. Then after filling all those things, press OK. We have modified the wind X region. Similarly, you need to modify wind Y region also. Select wind Y, modify lateral load. The wind speed that we have selected in the X direction is 33. Similarly, here also you need to select it as 33. The terrain category we have selected as 3. The structure class we have selected as B. The risk coefficient factor we have selected as 1. The topographic factor we have selected as 1.13. And similarly, the top story will be of story 10. The bottom story is of the story 1. So as I told that here is the major difference. We have selected in the wind X as 0 degree. So automatically we need to select in the wind Y direction as 90 degrees. After selecting 90 degree, press OK, then OK. So we have defined, and also automatically we have applied the wind load on the structure now by defining these terms. After defining all these terms, press OK. So as I told that these terms will be discussed later, that is the load, the load patterns we have discussed. The next point is the load combinations. The load combinations can be found out by IS 1893 Part 1 2002, that is the earthquake resistance design of the structures. From this here we can find out the load combinations which we want to apply on the wind loads. On page number 13 here are some of the combinations that it is given. That is 1.5 dead load plus imposed load. Imposed load is nothing but the live load, and the next is the 1.2 dead load, live load, plus or minus. In case of EL, we need to write it down as wind load. That is wind load in X direction and also the wind load in the Y direction. For example, 1.2 dead load plus live load plus wind load in X direction. Again, the next combination will be 1.2 dead load plus live load plus wind load in Y direction now. Similarly, 1.2 dead load plus live load minus wind load in X direction, and 1.2 dead load plus live load minus wind load in Y directions. Similarly, you need to find out the different combinations from these four load combinations we need to find out. These load combinations can be applied in the Etabs, like go to define, in the define find out where the load combination is, press on load combination. So here is the icon which is the type of the load combinations. Then press add new combo. So by pressing add new combo, it is asking that the dead load is how much we want to add and the live load which we want to add. So in the first case, I have told that it is of 1.5 dead load plus live load. So I need to type it as, here the scale factor will be 1.5 dead load. Then again go to add, I need to select as live load. It will be of 1.5. After adding, press OK. So my load combination 1 will be of 1.5 dead load and live load. Similarly, again I need to add the load combination 2. That is, the load combination 2 is comprises of 1.2 dead load plus live load plus wind load in X direction. So I need to add, the dead load will be of 1.2, add, then again the live load will be of 1.2, then press add. Again I need to select wind in X direction. It will be of 1.2 in X direction. Then press OK. Now the load combination 2 is added now. Then again, now go to we need to add in Y direction. The dead load will be 1.2, add, then again I need to go it for live load, that is of 1.2, then press add. Similarly, now I need to select wind in Y direction, that is of 1.2, then press OK. The load combination third is added now. Now the next part is the load combination 1.2 dead load plus live load minus wind load, that is in X direction and Y direction. So dead load will be of 1.2, add, live load is also of 1.2, then press add. In wind X direction I need to, that is minus 1.2. After that press OK. By applying all the load combinations, I will get it as 13 load combinations by combining all these combinations here. That will be of 13. Then press OK. After pressing OK, you need to check the model whether all the loads or the joints which you all have assigned is correct or wrong. So go to analyze. Then next, check the model, tick all the things which you want to select. By ticking, it will select the up to 1 mm it will select. Then press OK. The model has been checked and the warning has been displayed. That is, model has been checked, no warning message were generated. This indicates that all the beams, columns or the slabs or the loads which you all have assigned is in the correct fashion. So after that you need to run the analysis now. So go to analyze, then next run the analysis. here is it is showing the here it is showing how the analysis here has been running. So this is the deformation after the running the analysis. You can even start the animations by which you can see how the building behaves. As I told that you can see the animation how the structure behaves. Here is the animation part. You can press it here, so you can see how the structure is behaving for the dead type of the load. Now you can even change the displacement of that dead load, and you can analyze how the structure behaves and how the animation will occur.